Okay, for our second example, let's look at water draining from a swimming pool, and the remaining volume of water after t minutes is given by V equals 200 times the quantity 50 minus t, quantity squared, and our units are in cubic meters. So first let's find the average rate at which water leaves the pool in the first 5 minutes. Remember, when you see average rate, think of slope between 2 points. So we're going to find the volume at 5 minutes minus the volume at 0 minutes over the time interval 5 minus 0. Plugging these in on our calculator, we should get negative 19,000 cubic meters per minute. So that's the average rate that water is leaving the pool. We're losing about exactly 19,000 cubic meters per minute. And remember, that's an average over 5 minutes. Let's find the instantaneous rate if the water is leaving at exactly t equal 5 minutes. So when you see instantaneous rate, you think derivative. So first let's find the derivative of v. And then don't forget the chain rules, so we have to multiply times the derivative of 50 minus t, which is negative 1. Now we want to find this instantaneous rate at 5 minutes, so let's plug in 5 for t. And we get negative 18,000 cubic meters per minute. So the average in the first 5 minutes was we were losing 19,000 cubic meters per minute. But at 5 minutes, you can see that that is slower than the average rate over the first 5 minutes. Okay, let's look at one more example. Let's find the rate of change in the area of this triangle as theta changes. And we want to do it at the instant when theta is 60 degrees. Now the first thing you have to remember when we're dealing with derivatives and trig functions is we need to be in radian mode. When we calculated the derivatives of sine and cosine, that was all with the understanding that we were dealing in radians, not degrees. Alright, so our units will be in radians. So when we have a triangle, we need to remember the formula for the area of a triangle. So 1/2 the product of the two sides times the sine of the angle between them. So that's an area function for us, and A is going to be theta. So we're going to write an area function in terms of theta. So to find the rate of change, that means we need to find A prime, and then we're going to evaluate that when theta is pi over 3. So we get an answer of 30. Now you have to remember what this represents. So we're dealing in area, and our sides are in centimeters. So it's going to be 30 square centimeters per unit for theta, which is radians.